Alright, D-Lab is back in the shop. Lots of repairs awaiting, but first I want to give you a quick update on that custom Johnson VFO that I created from many other radios and parts. That's the VFO model 123. Okay? I thought that I had the project completed, but when I hooked it up to my Johnson Viking 2, I found that it did not even begin to operate on 80 meters. It worked fine on 40 and up, but 80 for some reason gave me no grid drive. So I got inside, did a little poking around, and I discovered that the signal on that band was extremely distorted and I couldn't calibrate it in. So the source turned out to be the repositioning of that internal wafer switch. I had to extend those wires and move it to the front panel, and that caused some capacitance and interactance, and it kind of killed the 80 meter band. Alright, so I thought, oh boy, because that's a band that I really wanted to operate on. So I came up with a very cool solution to the interactance of that switch, and that was to remove it and install a custom D-Lab circuit board. I'll show you guys that in a second. Then I ran across another problem. I found that the VFO would operate great on the bench, but when I hooked it up to the transmitter, the signal was being pulled down. Obviously an impedance mismatch between the Viking 2 and my VFO. I did a little reading and found that Johnson on the VFO-122 specified you must use RG59 coax at approximately 36 inches long to provide that impedance match. I thought, oh boy, that's probably what I have going on. So I removed the coax connector from the rear of the VFO. I installed the RG59, and guess what? I got grid current, but still not enough. So the next step was, how can I improve that signal, get a better match to the transmitter without going through a bunch of hocus pocus with caps and resistors? Solution was, install a cathode follower circuit. And I did that with a 6C4 tube. And it's on the back power supply panel now, so the VFO feeds that. So after I give you a little guided tour of the completed VFO project, we'll zero in on that cathode follower circuit. I'll provide you a schematic. If you want a copy, let me know. I have JPEGs available I can send to you. Then we'll hook up the VFO to my Viking 2. I'll go through each band and you can see the grid current. So far so good. I can't wait to put it on the air. So the VFO is out of the cabinet, side cover is removed. I'm going to zing in here so you can see my little circuit board. This is a 6C4 tube. My little board sits right down here. And what it consists of are 4 relays. Okay, they're PC mount, medical grade, gold contact relays. Right? The switch now up front only supplies switched 5 volts to the coils of these relays. When you're in the 160 and 80 meter position, all the relays are de-energized, and that makes the proper connections for that band. When I go to the 40-10 meter, these 3 relays all activate, and that does the appropriate switching for the other coil and cap assembly. And then when you go to the next position, which is 11 meters, this 4th relay kicks in, which adds the capacitance to lower the frequency for the 11 meter band. The board fit in here really slick. Here's the back side of the VFO. I did make one addition since the last time you saw this project, and that is this octal plug. I thought, you know, this power supply was designed to support a VFO 122. So I thought, you know, for troubleshooting, I should go ahead and install a socket that's wired the same as the VFO plug, and that's what I did. So now if I'm working or need to do some comparisons, I can actually power these VFOs on the bench rather than having to have a transmitter to fire it up. So that was just a little nicety, okay? It wasn't necessary. I also added the coax, which is the RG59 with the connector that goes to the transmitter. Alright, let's go ahead and fire this thing up. I'll show you its output on a scope, and then we'll take it in and hook it up to the Viking 2. Alright, bottom side tour of the 6C4 cathode follower circuit. Got a nice vintage ceramic 7-pin socket here with silver contacts. This is a 1 millihenry coil, and then some associated resistors, which you can see on the schematic. Okay, just a handful of parts. It cost you about $5 to do this. This is the RG59 cable that goes to the transmitter. Over here is RG174 coax, which is grabbing the VFO signal off of the coupling cap from the 6AU 6 tube in the main VFO cavity. All right, I've got the VFO fired up. We're on the 160 80 meter selection. When I turn the switch, you can hear the relays pulling in. Okay, let's take a look at the scope. There's my signal for the 160 80. There's 40 and 11 meters. Okay, let's hook up the VFO-122 real quick and see how it looks. All right, I've got the VFO-122 connected. We're on the 160 80/40 selection. Okay, I have to use a key to actually spot this VFO because I did not put a spot function on that connector. It's simply there to supply power. So when I hit the key, we'll see the output. Let's go to the scope. That is the 160 80. Notice the strange harmonic. I'm not sure why that is, but it seems like all these VFOs seem to have that just on that band. Okay, now I'm going to go to the 40 through 10. You see that's much cleaner. And here is the 11 meter. That's clean too. But it appears as though all these VFOs suffer on the 160 meter output. Alright, I've got the VFO-123 temporarily connected to my Viking 2. I'll go through each of the band selections and I'll show you the grid drive on the Viking 2. It's pretty impressive. Now here we go. I'm on the 160 meter band. We're just going to look at the grid current for each band. Spot the VFO just like you would a VF-122. You can see we've got plenty of grid drive on 160. Go to 80. Get my buffer up there. There we go. And there's my grid. You can see I've got a megaton of drive on the 80 meter band. Before, that was dead. Alright? Go to 40 meter. Now I have to advance the switch on this VFO to that band. Same deal. There's my grid. Megaton of drive. Alright, so we'll jump right up to 10 meter band. And then we'll put this to 11 meters, right? Because I want to show you that position. 11 meters is always touchy on these Viking 2s. But here, she's pretty smooth. Once again, plenty of drive. So on 11 meters, it quadruples that frequency. So it's coming in around 6.5 megahertz. And that's why you usually find that the grid indication has a much quicker peak. But this thing's working like $1,000,000. Alright, so now let's listen to the purity of the signal on my National 183D. I'm back on the 80 meter band. Let's see if we can find the VFO. Here she is. I don't hear any kind of hum. She sounds super clean. Next step is get it on the air. So how cool is that? The VFO-123 is finally ready, teamed up with the Johnson Viking 2 awaiting the initial QSO. And if you want to see it, you need to come back to D-Lab this weekend because the Hammared Ham will have it on the air.